Hi everyone, today we'll be studying an important topic called heat. Alright, I know you all know what heat is, the sensation of feeling hot or cold if something lacks heat. In winters, we want heat. What is heat? How is it transferred? We will go into the mechanics of it. Okay, when your mom is cooking, what is being transferred? How is it becoming hot? How is it being cooked? In winters, why do we feel cold? How does it rain? How does wind blow, breeze blow? All of this is related to heat. Heat is an important chapter. Okay, we will go from the basics to complicated parts as well, but you will enjoy it. So let's start. Alright, what is first of all calorie? Okay, calorie is a unit of heat energy. We categorize heat as energy. Okay, heat is energy. Okay, it is transferred from one thing to another. Energy can neither be created nor be destroyed, it can only be transferred. Alright, so a calorie is a unit of heat energy. How do I measure that energy? I will measure it in calories. Okay, it is defined as the amount of heat required to raise temperature of 1 gram of water by 1 degree Celsius. Okay, so if I want to measure what is 1 calorie, it is 1 gram of water. Okay, 1 gram water in grams. Yeah, heated. Okay, we increase the temperature by 1 degree Celsius. Okay, if we heat it and the temperature is increased by 1 degree Celsius, how much heat was this? This was 1 calorie. 1 calorie. People measure calories in food, okay, in their drinks. Okay, if someone is fitness oriented, they would know how many calories are there present in their food. Okay, how much energy would they require to burn all of that? That is calorie. In simple terms, what is calorie? Burning. Okay, you heating. How much heat, how much burn is required? How much? That is calorie. SI unit of heat energy is joule because it is energy. Energy is always in joules. Okay, joule. Joules. 1 calorie is equivalent to 4.18 joules. This is important for question point of view. 1 calorie or 1 cal is equal to 4.18 J, called joules. Fine. Okay, good. Now let's get into important things. Alright. Temperature is a measure of the average kinetic energy of particles in a substance. Now we come up to a subpart called temperature. Okay, what is temperature? Temperature is a measure of average kinetic energy. Okay, whenever you put heat on something, okay, the particles start moving inside it. Have you ever seen your mom make tea? Okay, she's boiling the water. What is happening to water? Okay, it is boiling. It is the particles inside the water are moving. The bubbling is forming and heat is being evaporated. Okay, what is happening? The particles are getting kinetic energy. What is kinetic energy? Energy you get through moving. Okay, you get through moving. Now if there was a heating pot and there were a lot of particles inside it, I heat it, these particles will start moving over here, over there, over here, over there. That is due to kinetic energy. Kinetic energy produces a lot of heat. Okay, so what is temperature? Temperature is the measure of average kinetic energy. Okay, how much kinetic energy is present I can tell by the temperature. Okay, as I am heating, temperature is rising, kinetic energy of the particles is also rising. Now I come to temperature scales. What are temperature scales? We measure temperature in different scales. We are used to degree Celsius. Okay, in the morning when news comes and people say today's temperature is this much, okay, in this much degree Celsius. In labs we go, we see this much degree Fahrenheit, degree Kelvin and all. Okay, So that all depends on the scale, on how we are measuring. We humans have devised various scales to measure temperature. Okay. Now we come to the Celsius scale. What is Celsius scale? It is commonly used for measuring temperature, the freezing point of water in a Celsius scale. Okay. So for Celsius, freezing point of water is 0 degrees Celsius and boiling point is 100 degrees Celsius. Simple. 0 to 100. Celsius is the most simple one. Hence, for broader things like temperature, the weather and all, we use this much. Okay, the Celsius scale. Remember, the freezing point of water over here is 0. Maximum temperature, as we move hotter and hotter, it gets hotter and hotter, it is 100 degrees Celsius. We come to the Fahrenheit scale. Okay, Fahrenheit. Remember the spelling. The Fahrenheit scale is commonly used in the United States. It is used in the America. Okay, the USA. The freezing point of water is over here 32 degrees. So for over here, Celsius was 0 degrees Celsius and 100 degrees Celsius was boiling. Now we come to Fahrenheit. And he says, for me, the freezing point of water will be 32. Okay, 32 degree Fahrenheit, degree F. Okay, and for me, boiling would be 212 degree Fahrenheit. This is used in USA. India, we use this. Okay. Kelvin scale. Another person was Kelvin. Okay, degree K. What did he say? Kelvin scale is the SI unit of temperature. So remember, international standard, international, the scale of temperature is Kelvin. Kelvin scale is the SI unit of temperature. SI unit is Kelvin, not degree Celsius, not degree Fahrenheit, but degree Kelvin. Okay, it is used in scientific calculations. So they may ask, which temperature scale is used in scientific calculations? Then we can say Kelvin. What is the SI unit of temperature? Kelvin. Kelvin starts from absolute zero. Okay. Absolute zero is minus 273.15 degree Kelvin. Minus 273 to plus 273 degree 1.5 degree Kelvin. Okay. 273 1.5 degree Kelvin. This is the negative, this is the positive, this is freezing for Kelvin, this is boiling in Kelvin. So minus 273 to plus 273. Also there is 0.15. Alright. Rankine scale. Okay. The Rankine scale is used in some engineering application. It is used for engineers. Okay. It is based on the Fahrenheit scale. Now this, what they can ask you, which scale is based on the Fahrenheit scale? You will say Rankine. Okay, it is based on the Fahrenheit scale. Absolute zero is 0 Rankine. So if I go over here and I do 0 over here, this is absolute 0 and the freezing and boiling points are, sorry, it would be over here, 491.67. Alright, and 671.67 Rankine R. Okay, it is not that important, but you have to remember these three. Okay. Relationship between various temperature scales. Now this is important. What if I have some temperature in degree Celsius, I want to convert it to degree Fahrenheit? I can also do that. Okay, but how will I do that? For example, I have Fahrenheit to degree Celsius, I want to convert it back. How will I do that? There are formulas given over here. Supposedly I had 100 degrees Celsius. Okay, I want to convert this to degree Fahrenheit. This is the formula. What will I do? I will multiply this degree Celsius by 9 by 5 and to this I will add 32. So this was 5 1 520 it was 180 plus 32, that is 212. Okay, 212 degree Fahrenheit. This formula is what I used to get Celsius to Fahrenheit. If I wanted from Fahrenheit to Celsius, I would multiply my degree Fahrenheit by 5 by 9 and I will subtract this 32. So first I will multiply, then I will subtract this. These formulas you have to learn. So the easiest one is Celsius to Kelvin. Okay. Supposedly I had 100 degrees Celsius again. I want this to be converted into degree Kelvin. What will I do? I will just add 273.5.15. This will be 373 degree Kelvin. Simple. Okay. If I want Kelvin, degree Kelvin to degree Celsius, what will I do? K minus 273.15. What is K? Okay. K minus 273.15. Supposedly this was 373 degree Kelvin. I want to convert this to Celsius. I will subtract 273.15. I will get 100 degree Celsius. Okay. Simple as that. Simple as that. Okay. Fahrenheit to Kelvin. I will again use this formula, but these are all interrelated. Okay. You have to note these formulas down. Okay. And utilize them to solve calculations. Okay. Over here again, absolute zero temperature is minus 273 degrees Celsius. Okay. If they ever ask you what is the absolute zero temperature in degrees Celsius, it is this much. Is considered to be the lowest possible temperature. What is the lowest possible temperature? Minus 273 degrees Celsius. Okay, this is the lowest possible temperature. What is the density of water? When is it maximum? Okay, density of water is maximum at 4 degrees Celsius. Okay, 4 degrees Celsius. Hand pump water is warm in winters because, okay, so this is a case study. This is important. If you see in villages, hand pump water, that they use hand pumps, alright. In winters, that water will be warm. It is coming from inside the earth. Okay. Why is it warm? Because underground temperature is far higher than ground or atmospheric temperature. In the atmosphere is pretty cold. Okay. But underground it is hot. So that hand pumped water will be hotter as compared to water that is flowing in the rivers, flowing through your taps. That is all cold. Right. Now, when these are some other facts related to heat, okay, these can be asked as multiple choice questions, so you should know about these. When iron and wood are kept in the sun, then iron becomes more hot as it is a good conductor of heat. Metals are always good conductors of heat. Good conductors of heat. So if there is a question of whether there is a metal placed and something non-metal or carbon based placed, metal will be more hot. It will be more hot. Iron becomes more hot as it is a good conductor of heat. Alright. Now we come to dark clothes. Okay. Dark clothes are heat absorbers, whereas white clothes are heat reflectors. If you've seen, your mom would tell you to not wear black in summers. Why? Because it absorbs heat and it becomes hotter for you. Whereas light colored clothes, white clothes, these are all useful in summers because they act as heat reflectors. They will not absorb heat, they will reflect heat away. Why? As the rays come, they reflect it away, bouncing back, if you remember. So Even this is also seen in cars and all. People having dark colored cars, okay, so like black cars, if you put it in the sun, it will get really hotter as compared to a white colored car. Okay, so dark is an absorber of heat, white is a reflector of heat. Ammonia is used as a coolant in refrigerators. This is ammonia, NH3. Where is it used? As a coolant. It's cool in refrigerators. What do you think when you open a refrigerator and gas is coming out? Is that air? No. It is comprised of various gases that they act as a coolant. Okay, what is a coolant? Something that cools, that produces cooling. Your ACs have coolants. Okay, everything has coolants. What is it doing? It is not letting heat come. It is taking away the heat. Taking away heat. Temperature of a light bulb is between 2000 degrees Celsius and 2500 degrees Celsius. You've seen a light bulb. So like this, there is tungsten in between. This is the glass, right? This is glowing. This is very hot. This glass, this light bulb's temperature will be between 2000 degrees Celsius and 2500 degrees Celsius. Silver is the best conductor of heat. Now silver is also a metal, but what is the best conductor of heat? Silver. Okay, you might think, why don't we use then silver inside light bulbs if it conducts electricity so well? Because it is a best conductor of heat. It also has a melting point. The melting point of silver is far below than tungsten. Okay, so in silver it will melt very easily. It will conduct electricity, it will conduct heat. Okay, it will absorb a lot of heat, but it will melt as well, and we don't want that. Okay, we want good amount of heat to be sustained at some temperature, that will be in tungsten. But what is the best conductor of heat? It is silver. Alright, it is silver. Latent heat. What is latent heat? You all have seen various forms of water. Okay, ice, liquid, vapor. Again, it can be gone to ice. That cycle you all know. Okay, the amount of heat that is utilized to change this form, is latent heat. Okay, latent heat is the heat energy absorbed or released during a phase change without a change in temperature. So if I change from ice, if I change this ice to water, temperature is not changing. Only the amount of heat that I am giving it is sufficient so that this changes into this form. Temperature has not changed, remember. Okay, but it has changed forms. All this heat is utilized in changing forms. Now the more heat I give it, then the temperature will increase. Okay, so that amount of heat that is absorbed or released during a phase change, this is a phase change, without a change in temperature, it is latent heat. It is measured on what? Reumer scale. REAUMER scale. The Reumer scale is another important temperature scale. The freezing point of water is 0 and the boiling point is 80. Okay, so 0 to 80 degree Reumers. Okay, here you can see solid is at this temperature. Okay, temperature will be constant for a while. All this while I am giving it energy is increasing, but all that energy is being utilized in melting it. This is latent heat, and it becomes liquid. Now it will stay some time liquid as energy is increasing, and it will stay as a liquid constant. Okay, again this is latent heat. Okay, again this is latent heat, and the temperature is constant. Right? This is what is latent heat. Latent heat of vaporization, latent heat of fusion. This is latent heat of vaporization. Amount of heat I am giving it, okay, so that it converts to vapor without a change in temperature. Okay. Calorimetry. Okay, what is calorimetry? A calorimeter is a device that is used to measure the heat energy absorbed or released during a chemical or physical process. Okay, so a calorimeter is a device used to measure the heat energy absorbed or released during a chemical process or physical process. Calorimeter measures the calories. Specific heat capacity is the amount of heat energy required to raise temperature of 1 gram of a substance by 1 degree Celsius. So I remember I was telling you, supposedly this is 1 gram of something. The amount of heat I will give it so that the temperature, okay, the temperature increases by 1 degree Celsius is specific heat capacity. Okay, this is the formula. Q is equal to M into C into T, where Q is the heat energy, total heat. Q is total heat. M is the mass of the substance multiplied by specific heat capacity. It is different for different substances. Okay, different for different substances. This is specific heat capacity multiplied by time or change in temperature with time. Okay, so let's take this temperature. From how to how? From 0 to 10 degrees Celsius, so that will be change in temperature. Let's go further. Transmission of heat. What is the transmission of heat? Now we all know, we all can feel heat. How is it being transferred from one place to another? Okay, it is an energy. Over here, see, this is process of heat transfer through direct contact. Okay, solids, in solids it is being transferred like this. This is called conduction. Wherever you see conduction, it is solid to solid heat transfer. Alright, conduction is the process of heat transfer through direct contact. Okay, you've seen conduction ovens, you've seen conduction gas, your gas stove. Okay, you need contact between the vessel, okay, and fire. Okay, you need this contact. This is conduction. Okay, conduction is the process of heat transfer through direct contact between particles of a substance. Convection is the process of heat transfer through movement of fluids or gases. In solids we had conduction, in liquids we have convection. Okay, when liquid boils, okay, over here if you can see, this is conduction, over here this is convection. Liquid to gas, heat is being transferred. Okay, this is how we make tea. Okay, this is convection, this is conduction. Formation of sea breeze. Now it is an important application of conduction and convection. Okay, application where we can see it being applied in the real world. Okay, so over here like making tea and all, one thing. Now we come to formation of sea breeze. What is sea breeze? Sea breeze is a local wind that occurs during the day near coastal areas, Goa, Pondicherry, everything. Like, sea breeze is a local wind, that means in that area only, that occurs during the day. It occurs during the day in coastal areas. It is caused by a temperature difference between land and sea. Okay, I'll show you. Between land and sea. So land is heating up, ocean is cold, okay, compared to this land. This difference will lead to some air blowing over here. That is sea breeze. Okay, sea breeze. What happens? Now let's go to what happens. During the day, land heats up faster than the sea. Okay, so land is hot, sea is cooler, not saying cold, it is cooler, okay, creating a low pressure over the land and high pressure over the sea, okay. This pressure difference causes cool air on the sea to move towards the land, okay. So if you've been to Goa or anywhere, if you are at the beach, there is cold air coming towards you, okay, a lot of cold air. Why is it happening? There is a pressure difference. This area is high pressure because it is over the sea. This is the sea. It is cooler. Cooler areas have higher pressure. Over here it is hotter. It is lower pressure. Okay, why? Because hot air is rising, okay. Air over this part will be hotter, it will rise up, okay, and over here the air will be cold, denser, higher in pressure. Hot air goes from here to here and cold air goes from here to here, okay. This is what is happening in this fashion, okay. Cold air is moving towards the low pressure area. This is a low pressure area because it had hot air, and hot air is moving towards the high pressure area, okay. This is the cycle that goes on. This is the formation of sea breeze. One more thing, radiation. Now we come to radiation. What is radiation? Radiation is the transfer of heat energy through electromagnetic waves without the need of a medium. How do you think your microwave ovens, they heat up the food inside? Okay, so if I have, supposedly, this is a microwave oven, okay, and I have put some food inside it, okay, in a plate. This is not in contact with any of the surfaces, okay, just placed over here, okay. How is it now come out to be hot? How? Due to electromagnetic radiation. This radiation is what causes it to heat up, okay. Electromagnetic waves. This is called radiation. We do not need a medium, we do not need contact for radiation to travel. Importance of radiation in our everyday lives. Radiation plays a crucial role in our daily lives, okay. Here are some examples. Sunlight, the light coming from the sun. This is also radiation. The sun emits radiation including visible light, some light we can see, and infrared radiation which we can't see but we can see through specific cameras. See, this is heat, this is his heat signature, and I can see it in an infrared camera, okay, which provides heat and light for various activities on the earth. That is sunlight. Cooking. What is cooking? Alright, radiant heat is used in cooking through methods like grilling and broiling, okay. So if you've seen a tandoor, okay, tandoor or a griller, you have this chhanni over some tandoor which has coal in it, and this is hot, but this is not attached to the coal, okay. This radiation is being transferred to whatever is put on this jali to cook, okay, whatever is put on this wires to cook, where heat is transferred to direct exposure to high temperature sources, okay. You do not need to touch it to know that it is hot. That heat is coming towards you. This is radiation. Radiant heaters use infrared radiation to warm objects, okay, radiant heaters. Thermal imaging. This is thermal imaging. This is used by wildlife capturers or people who want to spot wildlife, okay. Since in the jungle it is a relatively colder temperature, okay. Now I want to spot an animal inside that, okay, over there. How will I do that? I will use an infrared camera that will show me an image like this of the animal so that I can spot it, okay. Infrared radiation is used in thermal imaging cameras to detect variations in heat and identify anomalies or hotspot. This is also used in medical fields, okay, to spot any difference or anything that is unusual inside your body, such electric systems or building inspections, okay. These are areas where radiation is used. Alright, so that will be all for today. I hope you liked the lecture. Thank you.